get started right on time. All right, we are ready to get started. Good morning. My name is Mohan Sani. I am the faculty director for this program. And I want to welcome you to what will be the first of our several live sessions where you get a chance to learn a little bit more in terms of some newer content, but more importantly, really respond to your questions and your concerns and an opportunity for you to interact live with not only me, but with our entire team who I want to introduce at this point. So I am joined today by Varun. Varun Podar is the co-creator and co-designer of this course. So he and I have been collaborating on this initiative for over 2 years now. So Varun, good morning and welcome.
Good morning, Professor. Morning, everyone. Glad to be here with you all and look forward to working with you on this journey. Excited. Thanks for joining us.
Then we have 3 excellent program leaders. We have Danny Malter, who's joining us, and he's a dyed-in-the-wool data scientist, and he is local in Chicago. Danny, good morning and welcome.
Good morning, Professor. Yeah, really excited to meet everyone and looking forward to the course.
Yeah. So, and then next we have Alistair. Alistair has been with us since the inception of this program and has done a stellar job of navigating, which is now like the 4th cohort, right, Alistair, through this program. So welcome to you.
Welcome. Hello, everyone. Thanks.
And lastly, Tayo, Dr. Tayo, right? He's not the kind of doctor that does any good to anybody. That's what I tell people. What kind of doctor are you? I said, not the one that does any good to anybody, but we are theoretical doctors. But and Tayo also has been supporting this program right from the inception, and he comes to us from Amazon Web Services. And good morning, Tayo, and welcome.
Good morning. Pleasure to meet everybody. Excited about this journey.
Yeah. By the way, this is your chance to tell us where you are dialing in from. So, yeah. Akhil, you got to tell us where you're signing in from. So we love
you guys,
to see
right? Just remember to see all panelists and attendees so we can all see. You don't need to do just all panelists.
Tina's in Chicago. Basil is from Singapore, long while away place. Jay is from Calgary.
Be a fun new feature for Zoom. Jersey. If you could like have a map like fly in with the pins from wherever.
Yeah. Dallas, Shreya's from Dubai, Cleveland, Stuttgart, Denver, North Carolina, Toronto, Mumbai, Houston.
Toronto, a hotbed of AI.
Yeah, Chicago, India.
Surabaya in Indonesia.
And Jakarta, Saloma, welcome. Long ways.
Two from Indonesia.
Yeah, that's fantastic. Asif from Chicago. So Atlanta, North Carolina. Another Cesar, also from Dubai. New Orleans, Amrish. Fantastic. So welcome everybody and good morning. So
or good evening.
Yeah, Ruhi from Seattle. Prachi, not to be left behind, from the Netherlands. Waters, Shanghai. Fantastic. So, as you can see, you are a truly global cohort, and that's what makes it so exciting, because this is not only what you're going to learn from us, but what you're going to learn from each other. So we really value the quality of the people. All right, so our game plan today, just want to take a few minutes to introduce the team that will be supporting you in this program. I will walk you through the learning journey and what you can expect on a module by module and week by week basis. And then we will talk about the requirements for earning your certificate. And this is where Varun will walk you through the assignments, the grading process, and how you get credit for the various components of the evaluative components of the program. Following which, I'm going to walk you through a complementary sort of piece of content that sort of complements the first session. And that is just provide you with an overview of AI and machine learning, and just talk to you about the different kinds of machine learning problems and the kinds of algorithms at a very, very high level You'll be digging much deeper into this, of course, in your first module. But I just wanted to give some additional color to because we can never tell you enough about the specificity of these. And then we want to save time for your questions towards the end. So just a quick word of advice on questions. So our chat window is designed for casual conversations like the, wishing us good morning or just, giving us a quick comment. But if you want a question addressed by any of us, please use the Q&A box and make sure that you're sending it out to all panelists and attendees. Okay, so that's our, so please don't put your questions in the chat box because they scroll away. It's kind of hard for us to keep track. Some of the questions our panelists will address, by typing in a response, but we will save some for live discussion towards the end. Okay, so that's our game plan. So let me introduce all of the people on the team. So, I have been at Kellogg, the Kellogg School at Northwestern for 28 years. And I wear multiple hats or multiple turbans, the way you want to think about it. So I have an appointment in marketing. So I've been part of the marketing department. I teach courses in technology marketing. I also run a research center on technology and innovation. And as part of that, I teach a product strategy program. And I have a chair in technology. And lately, just a month ago, I was given an additional responsibility to head digital innovation at Kellogg. So my title is now, quite a mouthful, but don't get too impressed. It's just more work for less pay. So that's what, and in fact, digital innovation this is sort of, as you can imagine, we're going through a big disruption in executive education and business school education with COVID-19. So I am sort of helping lead the faculty through what we need to do from a technology standpoint. How do you flip the classroom, and how do you do live streaming, and so on and so forth. So that's what we're working on. As I was telling you earlier, Varun, he's an adjunct lecturer of innovation and entrepreneurship, and he has been the curriculum architect. He and I have worked together to design this program, and a ton of hundreds and hundreds of hours have gone into the design process. So he continues to steer it and guide it, and also to work with all of the case studies and the companies that we work with. Dan Chow is our representative from Kellogg Executive Education. So he's the senior director and responsible for all of our online programs. And then, as I was saying earlier, our three program leaders, Alistair, Tayo, and Danny. So that's the whole team that's going to be supporting you. And you can lean on us for help, for advice, for perspectives throughout the program. So this, I think, really differentiates us, right? This is one of the core value propositions of this program, that you are in good hands and you will be supported, you will be, guided, you will be mentored, and you will be, you're interacting with real people here, really skilled people. This is not just about watch a video and you're done. There's going to be a lot more than that, right? So let's look at you now. You looked at us. Now let's take a look at you. And so 2/3 of you are from the United States, but the rest of you are spread all over the world. In fact, we have Canada, India, Australia, Indonesia, and many other countries bringing up. So we have, typically in a cohort like this, we will have 20 plus countries represented. You also have come from a very, very diverse set of industries, which is interesting. This is not a tech course, so you got a whole bunch of technology folks here. IT services is just just 13%. We have consulting, we have healthcare, we have BFSI, and by the way, for the first time in the top 5 is FMCG, fast moving consumer goods, or what we call in the US CPG, or consumer packaged goods, but still a broad variety of other industries represented. So,
and also what's fascinating, Professor, this time is that the spread is very even. The countries in the other bucket, and that many of them are in that 2% range. Even the work, you can see it's very balanced. It's not skewed towards any one cohort. It is just magnificent.
And what we love about this is that as you get to do your industry specific AI blueprints, which will be halfway through the program, which I'll tell you about in a minute, we gain from the diversity of the industries, because the issues that are relevant in mining may be very different from the issues that are relevant in consumer products, which may be very different from B2B industrial. So we really gain from the diversity of the cohorts. What really blows me away, and actually blew all of us away here, is how experienced this cohort is. 80% of the participants have more than 15 years of work experience. That is just absolutely phenomenal. So these are you are very senior executives, you are in decision-making positions, and we are so proud and so honored to have a cohort that is as experienced as you, because since the inception of this program, we've been targeting it at basically at C-level folks, at people who are decision makers, who are sort of responsible for looking at a business function or a business unit, because this is really a course on AI strategy and leading digital transformation. So we are so glad that the cohort really reflects the level of seniority, the level of experience, the level of decision-making authority that we are looking at. So, and by the way, this is a record. Our cohorts are becoming more and more senior and experienced. So that's about you. But let's hear a little bit from you. What motivated you to join this program, right? So this is something you can put in the chat window. Just make sure your chat is set to all panelists and attendees. So why are you here? What motivated you? What do you expect to get out of this program? Let's just type in our brief responses so to get a flavor for. It really helps to know each other, right? AI is the future, okay? And implementing AI strategies in your organization, Ashish is saying. What else? Digital oil field. Yes, we will talk about oil field. Unknown unknowns. Yeah, coronavirus being one example, right?
Is that Donald
Innovation and
Rumsfeld?
business transformation. Adapt or perish. Love it. AI use cases. Patient healthcare. We will do a lot of healthcare cases. Deep learning platforms, startup, AI and digital marketing, small businesses. Yes, we will talk about AI or a shoestring. Pivot on to the next big thing, a playbook, get inspired, industry applications, finance, improving the quality of decision-making, AI and treasury, support functions, regulation, yeah, very, very important, predictive analytics, transformation, digital transformation, right? Hugely applicable to all industries. AI for telco and media. Yes, Ruhi, we'll tell you a lot about that. SCM, yes, we will focus on the logistics ecosystem. FMCG, management consulting, people versus AI. Love it. We are actually going to talk about this idea of assisted intelligence, not artificial intelligence. It's not about AI versus people. No. Love it. Love it. So these are great examples of why you're here, and they are here for the right reasons. I'm glad. Now, the other thing that we want to do is to look at your level of knowledge of AI and machine learning. So, this is just to make this simple. Maybe I'll give you 3 words, right? So it's like you can either type in expert, or you can say moderate, or you can say novice. All right, moderate, novice, moderates, novice. Okay. I think we are split 50-50 between moderate and novice, but with a few people, I love how you're saying expert / moderate, which is true. Nobody's a complete expert, right? So yeah, non-engineer data scientist, moderate on the way to becoming an expert, Ashwin. I love it. We are always on the way to becoming an expert. We can always learn more, right? So, okay, so that's good to know. So, and by the way, just to set expectations very clearly here, you don't need to have any prior knowledge. You don't need to have any prior expertise. We're going to walk you through from the beginning and build you up from there. Okay. All right. So let's talk about the learning journey now. What can you expect in the program? First of all, we just want to sort of step back and talk about what we do at Kellogg, right? So what we believe in at Kellogg, we really believe in growth, right? So we believe that we want to build leaders who have the growth mindset, because we believe that growth is it's not. I always like to look at a journey in 3 steps: mindset, right, to skill set, to tool set. So growth also progresses along these. So growth is a mindset, then it's a set of skills and a set of tools, right? So that's what we try to do, is that we are educating and equipping and inspiring growth-minded leaders. And we believe that these leaders are going to exploit the power of markets to create lasting value, and do it in a wise way. Wise, by the way, what is wisely leveraging mean? It means that you have to think ethically, you have to think responsibly, you have to think morally, you have to think about the societal, the environmental, the equitable nature of decisions. And that is something that you'll see reflected in this program too, because we've spent a fair bit of time in the final module talking about responsible and ethical AI. So in fact, if you want to double click on this mission for this particular program, I'd say to educate, equip, and inspire growth-minded leaders to transform the organization and wisely leveraging the power of AI to create lasting value for your company. So that's how I double click on this, right?
Professor, before you move on, could you just quickly clarify like skill set and tool set? I think I know the difference, but I just want to be sure.
Yeah, so skill sets is, for example, analytics, understanding how to use analytics and understanding the difference between predictive and prescriptive and descriptive analytics is a skill set. But being able to use Stata or Python or R, or NIME or RapidMiner to actually run analytics models is a tool set. So that's the distinction, right? So skill sets is competencies, and tool sets are actual tools that you use to put your competencies into action. So that's the distinction I make. Okay. All right. So why us, right? Why this program? Because there are a number of other AI programs that you can take. We're glad you chose this, but let me tell you a few things about how we thought about this program when we created it. The first thing that we asked ourselves was that if I'm a business leader, if I'm an executive, how should I approach this whole domain of artificial intelligence and machine learning? I'm not a data scientist. I'm not an expert in algorithms. I'm not going to write code. But at the same time, I need to know how to harness the power of AI for my organization. So what you need to do as business leaders is to understand where and how you should put AI to work in your organization, right? So the core idea is use cases, right? Use cases. So that's really kind of what we focused on, use cases in 2 ways, across industries and across the enterprise value chain. So enterprise value chain is the horizontal view, right? Which is, it looks at the different functions, which is, managing customers or supply chains and so on. But then vertical view is different industries. So what we have done and worked very hard to do is to look at and bring to you use cases of AI in action in a wide variety of industries and a wide variety of applications across the enterprise. So we have 50 plus use cases and case studies that are included. And these are case studies with real companies that we have personally worked with or personally interacted with. And it's about real traction, so that we're not talking about the theory. So sometimes I get frustrated when I take a course or program and you learn a lot about theory and algorithms, but you don't see how it can, at the end of the day, how do I use this for HR or interviewing candidates or, reducing customer churn or improving predictive maintenance for my turbines? Those are the sorts of questions. So we start with the business problem. We start with the business use case. And then we sort of, give you enough understanding about algorithms, tools, and platforms so that you can guide your data science teams. But this is not a data science course. This is not a course that will get you deep into the algorithms. So that is one core distinct feature. The other thing that is unique is that Varun and I have worked hard to create a variety of strategic frameworks that are proprietary that have been developed specifically for this course. You're going to experience these as you go along. You're going to start in your first module with this idea of the AI canvas, which is how you actually build a business case for an AI initiative. You're going to learn about other frameworks like the CX DNA or the consumer experience DNA, which allows you to map and analyze customer journeys and the AI use cases for customers. We're going to talk about the AI radar, which allows you to understand where are the opportunities, or the low-hanging fruit for your organization. You'll learn about a variety of such tools, the AI capability maturity model, the responsible AI framework that we have designed specifically for this program. The other thing that past cohorts and your colleagues have found very valuable is the capstone assignment, which asks you to build a playbook, an AI strategy playbook for your organization. So you're going to leave with an actionable end-to-end AI strategy, which you will summarize in the form of a memo to the CEO. So this is something that you're going to actually find that will help you in your job, in the current responsibility that you have. So these are some things that we believe distinguish this program. And in addition to this is the fantastic program leaders and the high-touch support that you're going to get with office hours, with the interaction with them. So that's and by the way, on the right-hand side, you have just some examples of the kinds of companies that we have worked with to develop these case studies. So what's the learning journey? By the way, you learned about the learning journey when we did the welcome webinar for you. So I'm not going to go over this in detail, except to point out that the learning journey goes through several pivots, right? So and what I mean by this is that you start out in the first module by looking at the tools and trends and applications. So that's where you are in the program right now, right? So this is sort of the first phase of the program. The second phase of the program is these three modules, right? So in these three modules, we look at the horizontal view of machine learning and artificial intelligence. So we're going to look at the enterprise value chain, managing customers, managing operations, and managing your business support function. By the way, these business support functions, we'll look at 4 business support functions: managing people, which is HR and talent management, managing risk, right? We're managing finance and accounting, and managing IT systems. So that really covers all of the staff support functions in your enterprise. Having done this horizontal view, we're going to pivot again and actually do a vertical look at AI. So that is sort of the third phase of your program. And here we're going to dive deeper into selected industries. We're going to look at healthcare. We're going to look at banking and financial and insurance. And we're going to focus on a specific sector that is very advanced in terms of AI applications, and that is autonomous vehicles and transportation and logistics, because this is where we see a lot of production use cases of AI at the highest level. For example, I drive a Tesla, and as you can see, Tesla is starting to launch more and more capability in full service, what they call FSD, which is full self-drive capability. The latest update last week was that the car now goes through green lights and stops at red lights without instruction from the driver. So you can put it on autopilot and it'll go through intersections and stop at stop signs, stop at red lights. So it's still a bit, it's a little creepy still, if you ask me, but we're getting there. So I think autonomous vehicles is an area where there's a lot of advanced work. The final pivot, which is the fourth and final aspect of the component of this program, is putting AI to work in your organization. So here we're going to talk about strategy and capabilities and the capability maturity model. And we're going to conclude with the discussion of AI in the enterprise, organizing for AI, agile team AI, and finally looking at the impact of AI on society, on jobs, and so on. So that is the 4 sort of, steps in the journey, sort of the module 1, module 2 to 4, modules 5 and 6, and then 7 and 8. So that is kind of how the journey will progress. Okay, so and you're just getting started. Now, one of the core benefits and value propositions that I was telling you about this program is the webinars. These are, by the way, this is the first of them, but we're going to do one every 2 weeks. And so today's webinar is Welcome and Intro to AI Applications, right? And then the next one we're going to do will be in module 3, in week 3, when you finish the first 2 modules. And here we'll talk about sort of AI across the enterprise value chain, bring you some additional content, related to enterprise applications, such as telecom, such as oil and gas, and so on. And the third one will be sort of when you're going to do the industry pivot. And there we'll actually talk about AI applications in select industries. And then finally, we will have a webinar towards the end where we will bring the idea to close, and we'll talk about how we put AI to work and focus on the industry blueprints and the AI strategy memo. So those are so this program over 8 weeks, in 8 modules, is punctuated by these 4 faculty webinars where you get a chance to directly interact with me and with Varun for specific things that you might find relevant, questions that you might have. Okay. All right. So that's the learning journey. And now let's talk a little bit about the requirements for earning your certificate, because this is not just fasten your seatbelt and sit back and enjoy the ride. You have to actually actively participate. You have to engage in, and you have to fulfill a certain set of requirements before you earn your certificate. So I'm going to turn it over to Varun to talk you through what are the requirements and to give you some flavor of the kind of work that will be needed at your end. Varun, over to you.
Thank you, Professor. So first, I'm going to tell you a little bit about the assignments, because that's kind of where the rubber meets the road as you start working towards your certificate. And what you'll see on this is a description. I think if you go to the next slide, Professor, you will see what are the most important points about the assignments. So there are eight total assignments, 1 per module. And these will be released by week with the module content. They're due at the same time that you're supposed to, within a week typically. When you finish the module videos, that's when the assignments are due as well. 7 module specific ones plus 1 capstone, which ties all the frameworks, all the assignments together. I'll talk a little more about the capstone shortly. But the idea of these assignments is to focus on AI ML strategy and basic tools. Kind of the strategy exercises, what Professor said earlier, will pick and shape your mindset and skill set. And the basic tools are targeting more the tool set side, where you can see how to apply some open source concepts and the basic sort of model building components in an assignment. Now, no programming needed, no prior knowledge needed. You'll be guided along that journey. So 8 assignments. To earn your certificate, you need to score 60% across those assignments. It's a 10-point scale. Now, what's unique is you will get a lot of direction from the program leaders. 3 assignments will be graded by the program leaders, assignments 1, 5, and 8. And this goes to show how we take in feedback from people like you and others that have come before you and incorporate it very quickly into future runs. We used to grade only the capstone. And after a couple of runs, kudos to Kellogg for making the investment and in the resources, and saying that we will give you more feedback at various touch points. So now 3 assignments are graded by program leaders, the AI Canvas, the verticalization blueprint, and the capstone. The other 5 assignments are graded by yourself. So what that means is you will have all the directions to complete the assignment. You will have a rubric that you will use to see what the scoring criteria is. And then you submit that. And then once you've done with the assignment, you will self-audit and sort of grade yourself based on the rubric and your answers versus the optimal answer. Now, we don't want all of you giving yourselves 10 on 10 for those 5 assignments. And that way you just do one other assignment and you're done. And so be careful that many of those 5 that are self-graded are randomly audited by our team, just to make sure that there's a check and balance in place, that you're actually not just giving yourself 10 on 10 for a weaker submission. So that's the first part, the assignments and how do you pass. Within this, we realized that the whole AI ML journey is a very deep, vast field. So within the assignments, we've created a core assignment, which is a mandatory set of questions that you answer that counts towards your score. And then we've created an optional deep dive that helps you go further and learn a few more details about the sort of assignments and do other things that will round out your learning, but they're not required, they're optional. So that's the optional sync, the infinite sync concept. My tip to you as you navigate this journey, attend the office hours. They will help you get pointers to the assignments, leverage discussion boards on Canvas. Some of the optional deep dives, not all. I don't think you guys work, you have busy lives. COVID's disrupted our time as well. So I realize you may not want to delve into all the optional deep dives. So you can delve into a select few of them. And then just kind of as you go, take the benefit of other people's lessons learned on this journey. And then you can apply that to your own sort of AI transformation efforts.
All right.
What, go ahead, Alistair.
I just wanted to add one more pro tip to your list, which is the resource library.
Right.
I could let you speak about that, but it's on the Canvas platform. Sometimes it's not hidden. We don't intend for it to be like that $1 million chest that was buried in the mountains of Colorado for a decade. But this is a 50-page document which will keep you very busy and has links and examples and a ton of information that will, so when you're thinking, hey, I'd like to know more about XYZ, always on the boards, I'm going to say, check the resource library. So,
yeah, and I'll tell you more about it in like 30 seconds. I think so that's a great point to add in here. I think you should definitely, anyone should, as you submit your assignments, refer to that for more tips. Let me tell you more about it in 30 seconds. If you go to the next slide, Professor, I can briefly talk through the assignments and then we can delve into the content as well. So this is the set of assignments that you'll go through the 8. It starts with Shoe as a Service. Again, because we covered a lot of this in the welcome webinar, I'm not going to go through each of these in detail, but that's the AI canvas. That's the framing of an AI initiative for any one use case. Some of you have asked the questions. I'm going to bring it up here, and Professor, look forward to your points on it. Is how do you pick an industry if you're industry agnostic, or how do you come up with one industry to apply this to? Because that applies to the canvas, to verticalization, and the capstone. So if share a little bit about guiding people on the industry.
Yeah, I think that first of all, the industry that you are in would be a logical place to start. And, and what we find is that these set of tools and technologies are of such broad applicability that they are useful no matter what your industry is, from education to retail to insurance to whatever. So that would be one. So look at your current, employer and current industry. Now, some of you may be between jobs or you might be looking to switch or change. So my suggestion there is to focus on the industry or the company that you want to work with or that you have an interest with. So that's another way to focus on what industry you should choose to do a deeper dive. The third approach would be that, let's say you're a consultant and you have a variety of clients and you find a particular client and their industry interesting and you want to learn more. So that would be another way to focus. So those are 3 examples. Maybe the fourth is that if you're an entrepreneur and that you have a startup company, so you might have direct applications for your particular company. So those are just ways in which you should pick.
Thank you. Thank you for that. I think there were 4 or 5 questions related to that. So hopefully that addresses for those of you who had that question. Now, there are 2 case studies which are basically putting you in the shoes of the senior execs making those decisions, Enerwind and Fuda. These are real, actual businesses with which Professor Sani has been on the board of one of the companies, Bhawan Cybertech, that's helped us create the Enerwind case. Fuda is run by Kellogg alums right here in our backyard in Chicago. And so you'll walk through their data science and AI journey, if you will, seeing different challenges and navigating them by you being in the seat of that chief data scientist or chief AI officer from a business strategy perspective. The last assignment, the AI strategy memo to the CEO, one of you had a question whether this is an academic exercise or you can send it to the CEO. Absolutely, you can send it to the CEO. In fact, we've had comments from students in the past that have said, I just submitted this to my CEO. And it's a thorough, fully vetted out AI strategy plan, very holistic in its approach, from knowing where to play, to how to go about executing it, what capabilities do you need, and finally, how to do it in a responsible, ethical manner. So that's what the course journey is. And if you see the asterisk points, they get you to that AI capstone. If you work towards it, you can get a jump start on your capstone. So
Yeah, so
last
everything from module 5 onwards will point towards or be a component of your final capstone assignment, and also the AI Canvas in module
Yeah.
1. So you see how they all build towards this sort of, ultimate capstone. Okay.
The optional assignments are not graded, by the way. That was one of the other questions. So they're not graded, but you can always get feedback through the discussion boards and office hours. All right. So the last piece, and before we turn over to the content, is the resource library. Alistair mentioned this, and I think it's a phenomenal resource. It's unique to anyone that's a part of the program. You don't get access to this outside the program. We realize that AI ML is vast, as I was saying earlier. It's not possible in an 8-week course to cover everything. And so we focused on some of the use cases, business applications, the value, the creation of business value and the transformation of organizations with AI. That said, there are other things that you might want to delve into, from knowing the trends, the algorithms, what sort of data sources can you leverage. Danny and I were just talking about data visualization tools, others that exist besides NIME. How do you look at the platform players? A lot of them have their own training. I mean, I've gone through Microsoft, Amazon's training. So a lot of these tools and deeper, richer resources that you can get into are covered in this resource library. It's one comprehensive document that's in the upfront sort of course orientation module, and a link that Alistair and Tayo and Danny can point you to. But it's a phenomenal resource that we put in a lot of work into. And I think it'll act as a guide for you as you want to delve deeper during the course, as well as when you're done with this program. So the primer on NIME, I'll give a shout out to that. That is going to be incredibly useful for your second assignment when you work on churn prediction using NIME. So with that, I will turn it back to Professor Sani, and we will dive into some of the content that complements Module 1.
Fantastic, Varun. Thank you for that very precise and detailed overview of the assignments and the deliverables and what it's going to take. As you can see, we have created a pretty diverse set of assignments that some of them are strategy assignments, some are more technical in nature, and and some are application oriented. So they will all add up to, I think, a very valuable learning experience. Let me just spend a few minutes now on complementing some of the content that you saw in the first, or will do in the first module. It's just a sort of another quick look at AI, machine learning, definitions, and algorithms, use cases, problems, and so on, right? So when we say AI or artificial intelligence, what do we mean? By the way, artificial intelligence has been around for a very, very long time, since 1958, actually. And in fact, when I was in engineering school, I'm embarrassed to even tell you how far ago that was. This was 1980, right? For almost 40 years ago, we had AI, but at that time, it was what we used to call symbolic AI, right? So symbolic AI was basically rule-based expert systems where you coded a bunch of decision rules, and then the program made decisions based on the decision rules that you had coded in. This was called GoFi, good old-fashioned AI, right? So very broadly speaking, AI is any program that can learn and that can sense, reason, act, and adapt, right? So what is interesting is that in this case, the only way that symbolic AI actually adapts is by adding more decision rules, right? So that was the limit. So it was quite rigid. It was quite, so you had to, in some sense, you needed to know the rules in order to make the decisions. Now, what was then created, starting in the 80s, in about 20 years ago, was the idea of machine learning. So machine learning was the notion that why is it called machine learning? Because the machine actually learns, and it learns as it's exposed to more data. So these are algorithms whose performance improves as they are exposed to more data over time. So this is what we call training, right? So training an algorithm, training a model is the idea that you sort of provide it with more and more data, and the predictions become more accurate over time as it consumes more data. So this way, the machine learns on its own, and it learns from the data that you provide it. So that's the distinction. So by the way, all of ML is AI, but not all of AI is ML. Now, a specific subset of machine learning which is probably 2013 onwards, right? I think it was 2012 when the first deep learning algorithm called AlexNet was created. So in those 8 years, we've come a long way. So the idea of deep learning, why do we call it deep? Deep is because it is a multi-layered hierarchical neural network. So essentially the way that the deep learning algorithms work is they are nothing but matrices, right? Matrices of which have nodes, and these nodes are connected in a network. And what you do is that you sort of you propagate a prediction, which is the weights that you put on. So there's an input, hidden layers, and an output, and you propagate the signal to make a prediction of the output by assigning weights to the nodes. Okay. And then there's an error in the prediction. You propagate that error back to the through the network, and then you adjust the weights and you go forward again. So you do this in literally millions of times until the output approximates what the desired output that you want. So that's the idea. So it's basically multi-layered hierarchical neural networks that really mimic the way the human brain makes decisions. Now, these deep learning algorithms are very useful for three particular use cases. One is recognizing speech, so speech recognition, such as what you see in Cortana, Siri, or Google Assistant or Alexa. The second use case is NLU, natural language understanding, which is text, unstructured text, semantic analysis of text. And the third kind of use cases that are very valuable for deep learning are machine vision, which is the analysis of images and videos. In all these cases, what you find is that there's a very complex set of unstructured data, and you make meaning hierarchically as you start to abstract away and look at the bigger picture, so to speak. So deep learning is being used today in, for instance, in autonomous driving uses deep learning, and analysis of chest x-rays for COVID uses deep learning for image analysis. All of your speech learning algorithm, when you go to Google Photos and say, find me pictures of cats, it's using a deep learning algorithm. So that's these are the different types of AI, right? Now, then, three types of AI, three types of learning approaches. So learning approaches are ways in which your algorithm learns. One of the sort of most basic and the most common ones and most widely used is what we call supervised learning. So in supervised learning, what you do is you label the data, right? So what we mean by labeling the data is that you said, this is the output that I expect, and then these are the variables based on which this output will be predicted. So for example, let's say that I'm trying to predict whether an email is spam or not, right? So what I will do is I will take maybe 10,000 examples of emails and label each of them manually. And said, this email is spam, this is not, this is spam, this is spam, this is spam, this is not spam. So basically I give it an output variable, which is 0 or 1, which is, not spam or spam, right? And then I give the actual text of the email to the algorithm. Now, what the algorithm does is it looks at patterns of text in the email that correspond to spam. And as it learns more and more data, it finds those patterns. Right? So that is supervised learning. The important thing in supervised learning is the data has to be labeled. By labeling, we mean that the output variable, the objective function, is defined. The ground truth or the right answer is known. And each data point, each observation that you provide, you said, this is the right answer. Now tell me how you get to it. Okay, so that's why we call it supervised. Supervised because we are providing the algorithm with a ground truth, right? Rishi, the algorithm, yes, it's the code. It's the code that we use in the program, represented in different ways. Sometimes it can be the underlying code. Sometimes it can be just sort of the high-level view of the algorithm. The next kind of learning is unsupervised learning. In unsupervised learning, we give the algorithm a set of data, but we don't tell it what pattern to look for. We don't tell it the ground truth. So a classical example of this is you're trying to discover what are the different customer segments in a population if you're trying to do segmentation. But this has also been used in like biology to find different species of plants or different species of flowers based on their characteristics. So there, what we do is that we don't know what segments exist. We don't know how many segments there are. We let the algorithm explore, and find clusters. So clustering problems very commonly are unsupervised learning problems. And the algorithm detects for us the clusters, and it then assigns customers to clusters. So that is unsupervised because we don't provide it a ground truth. And by the way, there is no right answer for unsupervised learning. You need to analyze the output, and the algorithm throws out these examples. So that's called unsupervised learning. Very useful for exploratory work, or where you don't want to bias yourself with a pattern that some preconceived notions about patterns. The third kind of learning is reinforcement learning. In this case, you actually let the algorithm make a decision and you give it feedback on whether it was right or wrong. If it's a right decision, you reward it. If it's a wrong decision, you penalize it. So it's kind of learning by positive and negative reinforcement, kind of like Pavlovian conditioning. And this is very useful for rule-based decisions, such as playing chess, playing Go, or for an autonomous vehicle making decisions in terms of braking, acceleration, and steering. So let's look at some examples of supervised and unsupervised learning. So first kind of supervised learning is a situation where your dependent variable or your output variable or your objective function is continuous. It can take on any value. So, simplest example of this is regression. So for instance, let's say you build a model that has only two variables. By the way, in practice, your model will have dozens and dozens of predictor variables, right? And the output that you're looking for, the objective function you're looking for, is number of customer complaints, right? So let's say that one of the variables that you look at as a predictor variable is the call center attrition rate, which is the rate at which your people are leaving you, your employees are leaving you. So this regression algorithm will basically find a relationship between the number of customer complaints and the level of call center attrition. So that's an example of a regression problem. So in a regression problem, the dependent variable can take on any value, right? Now, in some cases, we find that the dependent variable can only take on limited values, which is what we call a limited dependent variable, right? So like we were saying, the spam example, or in this case, like, you want to predict whether a customer is diabetic or not, whether this transaction is fraudulent or not. So then you have a yes, no, or a 0-1 decision, right? So in this case, we need a modification. This is a classification problem, because in a classification problem, we are grouping these responses into two or multiple categories. This is where we use classification algorithms like logistic regression or decision trees. So let's take a quick pop quiz to see if you're listening. You're running a large retail company that's selling winter wears, and you want to predict how many coats you will sell during the upcoming season. So what kind of problem is this? Let's throw up a poll. Is this a regression problem, a classification problem, or neither? Donna, Narayani, please put it in the poll. I don't want it in the chat. Just click on the button. All right, let's close the poll, see where we're at. Fantastic. 88% of you got it right. It is a regression problem because, the dependent variable here is sales. And then you might have, by the way, we worked on a use case like this with Microsoft and Fruit of the Loom. And what they found is that when the temperature drops by 12 degrees, that's when people start to buy more fleece. That's where the winter wear starts to sell. So that was an example of a regression problem. Okay. Let's look at now unsupervised learning. As I told you, unsupervised learning typically explores inputs without being given an explicit output variable. So this is used to find structure in the data. So here we have an example of groups of customers, and let's say you're trying to find the value or the spend, the value of customers, right? So there are two variables that you feed the algorithm, which is the level of spending for the customers and the age. So as you look at the level of spending and age, you find that this is one cluster and this is another cluster, right? So C2 and C1. So the algorithm will find these two clusters and say you've got segment one. Well, in this case, segment one are the younger people who are high spenders, right? So this is what we can call the young high value segment, right? And these are older, less value segments. So that is the example of a exploration problem, right? So essentially this can be used in two ways. One is to sort of group or cluster, and the other is to actually narrowing the feature set. Let's say you start with 100 predictor variables and you want to know the 10 or 20 that matter. Then the clustering will actually tell you which are the variables that are significant. Okay. And reinforcement learning, as I was telling you earlier, is about training an algorithm based on correct and incorrect decisions. And this is particularly helpful when you cannot collect training data for all scenarios and you want to use simulations or simulated observation. This is how autonomous vehicles are learned, the edge cases, because you keep feeding them examples of scenarios and then they make decisions and then you decide if the decision was wrong or not. So that's reinforcement learning. Okay. So the recap, we talked about 3 kinds of learning. Right, supervised learning, where you give it the algorithm a labeled data set. Unsupervised learning, where the algorithm learns based on unlabeled data and finds the pattern. And reinforcement learning, which is learning based on reward and feedback. And then we talked about different kinds of types of algorithms or decision problems. Regression, where you predict the values and outcomes in continuous ways. Clustering, where you're finding groupings in unstructured data or in sort of unlabeled data. Classification, where the dependent variable takes on limited values. Dimensionality reduction, which is a form of clustering where you're actually looking at variables that are important, the underlying dimensions, that fewer set of dimensions in the data. And reinforcement learning, which is how you teach an algorithm based on reward and feedback, right? So these are the types of problems that we've given you some examples of type of problems in this case. So how do we choose the approach, right? So this is a decision flow chart that you can use. So first question you need to ask is your output data categorical or not, right? Which means can it take on limited values or does it take on any continuous value? If it does take categorical value, then you need to ask, is my data labeled or not? If it is labeled, it's a classification problem. If it is unlabeled, it's a clustering problem, right? If your data is quantitative, which means it can take on any value, then if it is labeled, you can use a classical regression. And if it is, unlabeled data, then you can use dimensionality reduction, which is an unsupervised learning. All right, let us then do a pop quiz 2, which is to just check, whether you've listened carefully to the types of learning and types of algorithms, right? So I have 2 statements here. Statement 1 is in supervised learning, the predictions are based on the training sample of previously solved cases where the value of all variables are known. And statement 2 is unsupervised learning is learning without a teacher. So tell me whether 1 is true and 2 is false, 1 is false and 2 is true, both of them are true, or both of them are false. Those are your 4 options. Let's throw out the poll. All right, let's close the poll. Okay, so a little more variation here, folks. Both statements are true. So while 49% of you did get it, but because in supervised learning, we are giving the training sample of previous cases where we are giving not only all of the predictor or features variables, but also the labeling the output variable, right? And unsupervised learning is learning without a teacher because you're not labeling the data, you're not supervising the learning. The algorithm learns on its own. All right, so that concludes our discussion of the program. Good luck with the first couple of assignments, and I will take about 5 minutes that are remaining to address some of the questions that have arisen. So
sure. I can throw up some of the questions, Professor. A lot of them have been answered. I think they've been fantastic in terms of number of questions that have come in. I think one is let's address this need around reinforcement learning and how it differentiates from, say, deep learning or unsupervised learning. I think that frequently comes up.
Maybe Tayo, you want to comment on this, or Alistair, you want to comment on sort of, just a double click on reinforcement learning, because there's some confusion about how this is different from other approaches.
Yeah, so I think the key thing about reinforcement learning, I always tell people to think about games. So think about Tetris, chess, Go. In fact, in China, it was the AlphaGo winning that Go contest that really spurred a revolution in AI. So it's about risks, rewards, and how that is used as feedback to train a model. So that's what reinforcement learning is for the most part. And so games tends to be one use case. The other use case tends to be sort of around robotics. So some robotic application would leverage that. In terms of deep learning, again, it builds on what Professor Soni talked about. It builds on neural networks. And as you expand those neural networks with several internal layers or intermediate layers, that is the deep aspect of it, which could potentially enhance things like computer vision algorithms. So big picture, think about reinforcement learning, think about your games, think about deep learning, lots of applications in computer vision, natural language understanding, leveraging those intermediate nodes to improve how those networks work.
Sort of abstract way in which as I think about that is like my kid. I mean, to me, deep learning there is her learning to recognize objects. Like this is a dog, this is a cat. The interesting part right now is the difference between a mouse, a squirrel, and a rabbit. So that's deep learning. It's object recognition.
And reinforcement learning is that they will stick their finger into an electrical outlet and get a shock.
Exactly. That is reinforcement learning. It's learning dynamically from those actions that, I shouldn't touch this. This is good. This is bad. If I scream or throw a tantrum, that might be bad. So that's intuitively, that's how I think about the two as different.
And if I can add, in the context of AI in the enterprise, and this is something that my startup was focused on as being really cutting edge in terms of bringing prescriptive analytics, the next best action to for Fortune 500 companies and their customers at scale in real time is this notion of winning. Like, what is the best solution that you can come up with? And so there's many sort of variations. You can have recommendations, but the beauty of reinforcement learning is once the algorithm knows nothing when it starts. So in the beginning, if it's playing a game against a human expert, whether it's chess or Go, it loses 100% of the time. But then slowly it starts to pick up. And then once it gets better, and after it wins, then it never loses again. Because it's gotten accumulated.
And what's even scarier, Alistair, is that you can substitute the human for an adversarial algorithm. So now you have, this is what AutoML is. And this was when Google first, their DeepMind team did AlphaGo and beat the world's best Go player. Then they created AlphaGo 0, where you substitute the human being for another. So it's algorithm against algorithm, and they fight against each other, and they play this game billions of times. And that AlphaGo 0 now beats AlphaGo and any human player. So AutoML is the idea that you can actually have adversarial algorithms, and they can win against each other. The same concept is being applied in what are called GANs, or general adversarial networks, which are where you look at images and you create deep fakes of images. So which is a sort of a very hot area, of course, in the world of politics now. So that is again done as sort of basically you have a real and a fake, and you're sort of competing to figure out whether you can detect the fake or not. Over time, the fake becomes so good that it's indistinguishable. So that's another example of this reinforcement approach. Okay, so
I think some of the questions around prescriptive nodes we'll touch on in the next webinar as well. And I think the discussion boards are a great forum to bring it up as well, to go into specific.
Yeah, these basic questions: what is regression? What is a node? What is the visual? So as you start to play with NIME, as you start to look at the workflow in a model where you can drag and drop nodes. So nodes are basically a form, a computation step essentially. So for example, a node might be a joiner node where you take one data set, another data set, and combine it. Another node might be an analytics node where you actually run a regression algorithm. So those are all something that you will learn more about as you get into the assignments, as you start playing with the algorithm.
I do see one final comment. It's actually in the chat, and I apologize if it got brought up. I might have been typing an answer to someone else from Rekha, and I apologize if I mispronounced your name. She says, I think an important point is the results of machine learning and AI is only as good as the quality and volume of historical data available in the organization. And then someone else said organizations spend millions cleaning up legacy data as part
Yes.
of an ERP and never reach the promised land. So that's
Very
something
important.
we'll
So not only
definitely
is the accuracy of the data, but also the bias, or the biasness of the data. And I will tell you that many machine learning models that had been calibrated in the pre-COVID days now need to be retrained, because the historical data generating process has changed, right? The underlying behavior has changed. So so you'll have to now sort of redo or rethink a lot of the forecasting models, because this is a black swan event. So you do need to think about the quality of your model is only as good as the quality of the underlying data and the data generating process. We spend a lot of time talking about this because 80% of the work in building an AI model is actually the data cleansing and data wrangling. All right, folks, we're at the top of the hour. So this has been a great session, and I hope this introduces you to the to sort of the richness of this course and the work that you'll have to do. Thank you so much for attending and spending an hour with us. And good luck as you move forward, and look forward to seeing you in a couple of weeks.
Remember to take the survey at the end of the webinar that you get. We take your
Yes,
feedback.
because we really do look at feedback and try to make these webinars better as we go along. Okay.
Thank you.
Thank you.